I'll talk a little bit of the start of some exciting work. So I work for the Center of Theoretical Physics and Computation and Theoretical Physics in Lisbon. Lately, we have been doing something that you all probably did. So if we have a net of some polyhedra, and we fold it, we get so you can fold up a net into a polyhedra. And what we are trying to do is exactly that, but at the micro scale. So these are some images of that represent what we are trying to do. We are trying to study the kinetics and how this process works at the micro scale. And while doing that, we stumbled upon some problems because the net at the micro scale cannot be folded by hand or by a machine. So we have to rely on thermal fluctuations and the motion being automated, so the self-folding of a net. And we have some problems with that because we know that a polyhedra can be cut in many ways. For example, the cube can be cut in 11 ways, but if we start adding faces, we have more and more ways of cutting, and we have to choose the best net to allow the self-folding of a polyhedra at this scale. One of the challenges is the errors that can be created by this. And another one that we stumbled upon was the fact that some nets fold into more than one polyhedra. So this is one of the simplest cases. And if we jump to the overhead, you can see, so I have a net here, which is the one that was in there. And it's the same exactly over here. So if I fold this net like this, I get something similar to an octahedron, actually. I don't know if you can see. Maybe the black wasn't the best option. And if I fold this way, this net, I get something like, okay, well, let's do it by hand. So I get something similar to a boat. It's actually called the boat polyhedron. Okay, so and this is a problem because if you want to fold something at the micro scale, you have to determine before if the net can or not fold to the polyhedra that you want. So the question is, how do I know if a net can fold into more than one polyhedra? And to tackle a little bit of this problem and to start exciting exploration of that, we created this database. So a database of this kind of structures. And there are some open questions like, is there any common net of two platonic solids? Yeah. And it was partially answered by Guehara, which is actually here. And it's a fractal net that's thought with infinite iterations to fold into both a tetrahedron and a cube. And there are a lot of studies about, for cuboids, also by Guehara and co-workers. And in this case, we have an interesting subdivision because on the left side, we have free unfolding. So to fold it, we don't actually use the same folds for the cases on the right. So we subdivided in these two cases, free unfoldings, like the ones on the right, and rigid unfoldings, where you use the same foldings for both polyhedra. For cuboids, we are currently, the maximum is 3 boxes from one net. It's this case for orthogonal foldings. And I invite you all to try to find new cases, new classes of common nets, and for that, and to collaborate with all of you, we created a Wikipedia page, which is still on draft, but you can already edit it, and try to fold a polyhedra, unfold it, and try to refold it in a new way. It's quite fun. It's an excellent puzzle, so please take a look at the Wikipedia page. My gift to you for the gift exchange is a paper describing the database and all the cases that we were able to find in the internet. So if you have more cases to add, please do it. If you want to find it, please do it as well. And that's it. Thank you.